A good morning to all of you. Hope you're feeling well today and are eager to hear our speakers and also participate in the debate. This session is now being filmed outside Stockholm and streamed via Zoom to all of you conference participants. This session and all the other ones are being held in English. And as I understand, we have around close to 200 participants. That is very promising, of course. My name is Charlotte Unger Larsson, and I'm a business developer at the Swedish Wind Power Center. I will moderate the introduction session. This session will set out the research scene, both from an international, EU and a national perspective. Firstly, it will address the importance and the possibilities of introducing a restart after the COVID-19. And secondly, it will present the development of a Swedish national strategy for wind power. And thirdly, it will address the transition into a 100% renewable system, both the opportunities and the challenges, and also to have wind power as a backbone. But before we go to the introduction session, I would like to welcome Susan Carlson. She is responsible for sustainable electricity in the Department of Research, Innovation, Business Development at the Swedish Energy Agency. Please, Susan.
Thank you, Charlotte. Hello, everyone. Good morning. Welcome to the Wind Power Research in Focus. It's great to have this conference today. I'm just briefly going to introduce the organizational team, and I'll talk a little about the motives for this conference. So this is a conference we do in cooperation with all these people and organizations from the Swedish Wind Power Technology Center. We have Sara Fogelström. We have from RISE, Stefan Ivarsson. Stand Up for Wind is represented by Stefan Ivanell, and we have from Energiforsk och Vindval, Åsa Elmqvist. And then, of course, from our part, the Swedish Energy Agency, you will later meet Pierre Tardier and Elektra Klaus today. So it's a bit sad we don't get to meet in person today, but what we will get to do is to learn about the latest research and development in this field. And I think that's an important message, that although there is a pandemic ongoing, development in the wind power sector is still going on. And what a year 2020 has been for wind power in Sweden. Just look at production numbers. However, there are still challenges we need to address, and we need development. And we need progress in research, that's for sure. For example, technology or technical development is still ongoing. So we can still reduce costs and improve tower materials and improve production by several means. And this is perhaps sometimes forgotten when we talk about the possibilities of wind power in the future. The future wind power is not what it is today. And I hope you will take that with you from this conference today. Also, as we have more and more wind power in our power systems, we need to address the questions that come with that. So how can wind power support the power system? How can it interact with other power production? And you will hear about that also later today. And then again, the possibilities to build more wind power. What we also need research and development on how to meet and minimize negative impacts on, for example, on the environment or social negative impacts of wind power, and make wind power even more resource efficient. And you'll hear also a bit about the wind power strategy in Sweden. That's a part of that too. So that's just briefly on what you'll hear. And this is the program as it looks. So we'll start with this introductory session altogether. I'll soon give the word back to Charlotte, and she'll introduce the speakers. And then there's a break. And both before and after lunch, you go into parallel sessions and you choose the sessions you want. And these are led by the organizational teams members respectively. And as you can see, there's a lot to choose from. I hope you have an interesting day, and have a good day. That's what I want to say. Back to you, Charlotte.
Thank you very much, Susan. So now we will kickstart the conference Wind Power Research in Focus 2020. And as I said earlier, we are going to, in this session, talk about the international perspective, the EU, and also the national one. And please, I would like to remind you that you could pose questions via the chat, and I will be able to post the questions further on to the speakers. First, we will listen to Pierre Tardier. He's a Chief Policy Officer at Wind Europe, and he will address the importance and the possibilities of a green restart after COVID-19. So please, Pierre, I guess that Pierre is with us on a link from Brussels, aren't you, Pierre? Hello, nice to see you, even though it's not in person. So please give us your talk about the transition, the green transition and the restart after COVID, please.
Good morning, everyone. For the time being, I'm not able to share my presentation. Let me try to do that. Okay, excellent. Look, thank you very much for the opportunity. Really appreciate this. I'm extremely sorry we're not able to do this in person. I very much look forward to a day where we can do this in person and get a little bit of interaction. That being said, I think this is a sign of the times that we're still able to pull together and think together on how to deal with the challenges of the day. So thank you very much for this opportunity. Now, Europe is really faced with a dual challenge at the moment. First, really kickstarting the European economy as it really reels from the consequences of COVID-19. And second, doing this in a way that doesn't actually worsen pre-existing challenges. And in particular, doing it in a way that is future-proof and helps address our climate change challenge. And I'd like to take a little bit of time to discuss the role of wind energy in addressing that dual challenge. Perhaps before we go into the detail, I'd like to spend a little bit of time sharing where we are at the European level in terms of wind energy installations. What you can see here is that Europe already has 205 gigawatt of installed capacity, enough to meet 15% of the EU's electricity demand. So here's the map of what it looks like across Europe. In the white bars, in the clear bars, you have the rates of installation in gigawatts. And in the red bars, the share of wind in the electricity mix in that particular country. So for Portugal, if I take an example, down in Portugal, there are 5 gigawatts of installed wind, enough to meet 27% of that country's electricity consumption. Another example, and many of you will be familiar with this, Denmark is the world record holder with a penetration rate of 48%. So a solid starting point for Europe, but of course, the political winds have accelerated when it comes to trying to address our climate challenge. The relatively new president of the European Commission, Ursula von der Leyen, has made a big commitment as she came into office to make the EU the first climate neutral continent by 2050. And this is now also supported by heads of states and governments who confirmed this in December late last year. This requires a radical change in the way that we produce and consume energy. And the International Energy Agency has taken a closer look at what this would mean for the electricity system. What you can see on this chart here is that according to the International Energy Agency, offshore wind and onshore wind would be the top 2 technologies in power generation, in the 2040s already, and really establishing their dominance in 2050, meeting together close to half of the electricity demand in Europe. The European Commission has taken its calculator out as well, and according to the EU long-term decarbonization strategy, meeting climate neutrality would require in the order of 1,200 gigawatts of wind energy, 450 of offshore wind, and the rest of onshore wind. So it's roughly developing another 5 times what we have today. And in the case of offshore wind, it's multiplying by 20 the capacity that we have. So this would require a remarkable change, but the industry is up to the task. We feel very strongly that we're able to do this, provided that the policies are in place. That being said, of course, and as my fellow speakers have explained, 2020 has been an extremely challenging year. It has really put the industry to the test, as the broader economy, of course. It has really rattled the wind supply chains, starting with suppliers in Asia that were first hit by the pandemic, and then translated into really daily operations throughout Europe. In particular, the south of Europe was struck very heavily, more broadly as society, but also in terms of wind production, wind parks production, development, etc. Up to 19 plants in Spain and Italy had to close, and other facilities had to temporarily halt activities in order to put in place the appropriate health and safety protocols. Everything got more complicated as a result, not just the production of wind equipment, but also the development. It became very difficult for people to move across borders, for equipment to be moved across borders as well, right? The EU moved very promptly to try and put together green lanes in order to make movement as fluid as possible, but these were very slow to be up and running. And the sector really felt the consequences, very deeply. And there were, very particular challenges also very specific to the wind industry. As Europe was really dealing with challenges in terms of personal protective equipment, the EU put in place an export ban in order to make sure that the PPE in Europe would stay in Europe, which was absolutely justified and appropriate in terms of policy decisions to make. That being said, one of the collateral effects of that is that PPE for developing offshore wind farms out in the EEZs were also impacted by this ban, right? So that has meant that development in offshore wind was temporarily halted as a result of that ban and made more difficult. Eventually, this was corrected. Policymakers at European level were fairly quick to make adjustments, to get the green lanes running, to recognize the specific characteristic of the energy sector as an essential to running the European economy. But that required a number of adjustments to be made, in particular in the months of April and May, where the sector was really hit very, very hard. Additionally, the difficult economic conditions across the economy meant less liquidity and meant that financiers were for a moment rattled and potentially at the risk of not going forward with more risk-averse projects. And for a time, there were genuine question marks about important financial investment decisions for very big wind projects in the spring. More broadly, of course, the energy system was really put to the test. And the most resounding example of that is the fact that electricity demand dropped very massively, in particular in the month of April in the larger European economies, by up to 20 or 25%. That has really put a stress on the energy system. In particular, that was completely unforeseen and challenged the less flexible power generation technologies. That being said, upon closer look, we've done a detailed assessment of how the industry has fared in the first semester. The first conclusion that we can draw here is that in spite of the very challenging conditions that I just explained, we were able to install a little bit more than 5 gigawatts across the EU. We saw in particular activity in Germany, in the UK, France, Spain, and fairly good activity in Sweden as well for onshore wind. And we expect that in the second half of the year, as is typically the case, the numbers will be even higher. And this is especially the case in the north of Europe, where summer months are very, very appropriate for accelerating installations. Another remarkable finding, I think, is that installations actually held up. In fact, we had a near record half year with more than 14 billion euros invested in wind. And what you can see on this chart, it looks like a downward increase, but you have to put in perspective that the last bar chart on the very right is only the numbers for the first semester, whereas all the other numbers are for an entire year. So these investment figures are very strong, and they're in particular driven by 5 very large FIDs in offshore wind, in particular in France, the Netherlands, and the UK. Onshore wind certainly took a hit. We did see delays in installations and fewer projects see the light of day, and as a result, more uncertainty and lower FIDs. But overall, what we can conclude from this is that in spite of the broader economic challenges, the finance community very much trusts the technologies and has decided to double down on wind. And more broadly, I think it's important to note that in these challenging conditions, wind met 17% of the EU's electricity demand and continue to power the European economy in these very challenging times. So wind is well placed to meet the dual challenge that I just explained, helping to kickstart the European economy and doing so in a way that is future-proof, and is certainly quite appropriate to help deliver the EU stimulus package agreed by heads of state and governments back in July, 1.82 trillion euros to kickstart the economy, 30% of which EU heads of states and governments agreed should be spent on climate expenditure. Now, how do we make sure that beyond continuing this momentum, showing resilience and throwing money at wind deployment, how do we make sure that the broader policy conditions are met in order to get the most out of wind energy? Well, first, it's all about implementing the national government's national energy and climate plans to 2030, which are meant to map out deployments of renewables, the implementation of energy efficiency, electrification, etc. The European Commission is doing its analysis and announcing it this week. We have done our own report cards. And what we find is that even though on paper, the national energy and climate plans add up to the EU-wide target of 32%, even a little bit more, the measures in the plans really fall short in many areas. And in particular, when it comes to planning and simplifying permitting rules and giving visibility to investors with their auction schedule and perspective for revenue. And therefore, I'd like to spend a little bit of time giving you our thoughts on the priority policies that need to be put in place. First, and I just alluded to this, it's all about simplifying permitting, and making sure, especially, that the relevant authorities have the appropriate resources in order to deal with all the permit applications. It's great for EU member states to have big wind volumes in their plans, but if they're not sufficiently staffed in order to deal with all the permitting, all these numbers are purely academic, and we will not get there. This is not about watering down environmental standards, quite the contrary. It's about making the system more transparent and more effective in order to deploy wind in an environmental sustainable way. Second, and this is something that has held up fairly well during the pandemic, making sure that national governments give investors as much visibility as possible on renewable energy auctions. When are they going to take place? What the volumes are going to be? What kind of budgets are going to be allocated to that? And what is going to be the support mechanism? And in particular, ones that give visibility on revenues going forward. This is really critical if you want to unlock investments. And we're very supportive as an industry of systems like contracts for difference that give visibility on revenue going forward. Crucially, of course, this needs to happen in a context of electrification. I said that the share of wind was growing in electricity, but at the same time, we need to grow the share of electricity in the energy system. It's only a quarter today. We know how to decarbonize that by growing wind, solar, and other renewables. But if we want to decarbonize the energy system as a whole, we need mobility to go electric. We need homes to be heated with electricity. We need much of industry to go electric, because that enables us in the most cost-effective and energy-efficient way to decarbonize those end uses. And crucially, of course, we need to have the infrastructure that underpins this electrification agenda. We said we're in a resource-scarce environment. The EU and national governments need to make every euro count. We need to use the euros where they will take us the furthest. And we can't afford to be making any investments today, gas pipelines and others, that don't fit in a climate neutral economy. The lead times are such that we can't afford to be making these kinds of mistakes and having sunk costs going forward. And finally, of course, and this is critical to Europe's global leadership in wind energy, we need the right trade policies, of course, to make our supply chains resilient, and that has been tested in the pandemic. But also we need to stay ahead of the curve in terms of research and development. There's been a tendency in recent years to really invest in newer technologies such as floating offshore wind, and to forget a little bit about bottom fixed and especially onshore wind. But as my predecessors on this conference said, we also need to stay ahead of the curve on onshore wind, work out new materials, make the turbines more circular, more recyclable, to get them to perform better and really meet the challenges of climate change. And that's absolutely critical to our global competitiveness. And if we do all this, we're convinced that Europe can actually chart the path for climate neutrality, grow its economy, and act as the gold standard for the global energy transition. Thank you very much.
Thank you very much, Pierre. Very interesting presentation, and it's so hopeful also that you say that although we have had a pandemic, there is a trust from the investors in wind power, so that's very pleasing to hear. But on the other hand, we're also talking about, will there be a second wave of the COVID epidemic? How do you think that would the investors still stay there? Do they still have the trust, or what do you foresee?
So I think in terms of the second wave, it's undoubtable that this will have, if it materializes to the degree that we see in the spring, an impact on installations and operations. That being said, I think the industry has learned a lot in the spring in terms of putting in place the health and safety protocols, in terms of making sure that they're able to work under these conditions, adjust their production schedules, etc. And policymakers have learned a lot, right? I use the example of the PPE ban for offshore wind farms, and these mistakes have been corrected, and we're able to build on that. That being said, of course, we have much to do. Make sure that the national recovery plans are indeed future-proof, that they really make the right investments to fight climate change, and bet on the right technologies to do that.
And I mean, at least I know in Sweden, the discussions with the government has been that you have your approval, the approval will last, or it will take about 10 years before you have your park. So it's very important to have some extension of this due to that you have delays in deliveries of the towers, you don't have the people there. How is the situation in the rest of Europe? Have you had a great ear from the politicians being able to help the industry in this situation?
Yes, I think for the most part, this is one of the things that's been very heartening in the pandemic, is that governments have by and large stuck to their plans, so they haven't used the context of the pandemic to delay investments, and they have adjusted the procedures where necessary to give more time for investors to make their bids, extended permit applications, etc. We have seen a particular challenge in Turkey, but that's been a bit of an outlier. So this has been fairly positive. That being said, Charlotte, you make a very important point about this very slow permitting processes that we see across Europe. And that is really perhaps the biggest bottleneck that we see to accelerating the deployment of wind. And when we look at the massive volumes that are required to meet climate neutrality, it's absolutely critical that this is tackled head on. And we see certain improvements in Germany. The industry is really zeroing in on this topic, and we need to see that type of progress across Europe in order to have any realistic chance of getting to climate neutrality.
Just a last question. You were talking about Denmark being the leader, so to say, and these figures you have here, 48% of the use of electricity. How do you foresee the journey until 2040, for instance? What will happen within only 5 years? Will there still be Denmark ahead, or will there be other European countries taking the lead?
I mean, certainly Denmark has been a front runner here. But that being said, we see very large European economies getting 20-25% of their electricity from wind energy, right? We see this in Germany, in the UK, in Spain, and I think it's a Europe-wide transformation. But as we said, it's really going to hinge on our ability to invest in the right grid infrastructure and having the right policies for broader electrification of other end uses. It's not just about growing the share of wind and electricity anymore. It's really about challenging the energy system to go electric, and to get renewables in end uses that have been heavily reliant on fossil fuels to date.
Thank you very much, Pierre. We will come back when we have the conversation with the other two presenters. Thank you very
Wonderful.
much.
Thank you, Charlotte.
So now I would like to welcome David Newell, and you work as an analyst at the Swedish Energy Agency, and you will talk more about the Swedish national strategy. And in the introduction, I talked about this being also a large collaboration, not only the authorities, but also the municipalities, etc. So please, David.
Thank you very much, Charlotte. Yes, as mentioned, I'm going to speak about the national strategy for sustainable wind power development that's currently ongoing in Sweden. So to put this all in a little bit of context, wind power development in Sweden and also the planning procedures that surround wind power development, I'm going to talk a little bit about those before going into the strategy itself. So wind power capacity, as we've seen over the recent years, wind power has developed extensively in Sweden, both in terms of the number of turbines as well as in terms of the capacity and the electricity production. And this development in Sweden has occurred across Sweden. Of course, it's more concentrated to the central parts of Sweden in the second and third bidding areas. But development has been fairly broad across the country, and new projects are occurring across the country. And in more recent years, that has been focused on the northern parts of Sweden. In terms of context in the planning process, in Sweden at the national level, there's no cross-sector planning at the national level for land-based wind, but there is for maritime-based planning. But when we talk about land-based wind, the planning tools that are used by the national government are chiefly national objectives and areas of national interest that are used to help guide the planning process. These areas of national interest for wind power are spread across Sweden, and they comprise about 1.5% of the total land area in Sweden. At the regional level, planning is also directed in a more offhand kind of way. It's through the national or the county administrative boards that take the areas of national interest and take and weigh those against other areas and other interests that are present at the regional level and help to use those to guide the planning process as well. But it's at the local level where the primary area of the planning in Sweden is occurring. At the local level, you have municipalities that are responsible for taking forward a comprehensive plan for developing not only wind power, but all other planning interests at the local level. And of course, in Sweden, it's required that there's a municipal approval of all new wind power projects. So given that context, we'd like to talk a little bit about the national strategy for wind power in Sweden. This is an initiative of the Swedish Environmental Protection Agency and the Swedish Energy Agency, and it's done through the Swedish Council on Environmental Objectives. And it's also done in collaboration with a number of other Swedish government agencies. And the plan is to have this strategy fully developed by December of this year. So you might question why we need a wind power strategy in Sweden if wind power development has been going on fairly well in the past several years. And as we look to the future, we can see that wind power is, we have here the different sorts of electricity generation that occur in Sweden. And we have hydropower on the bottom, and then we also have nuclear in the yellow, and then we have other renewables and wind along the top in the light green. But what we do see is that we anticipate a decommissioning of nuclear as we move into the decades into the future. And because of that, and also because of increased consumption of electricity, we anticipate a minimum of a deficit of 100 terawatt hours in electricity production. And the question is, how do we make up that production deficit? The Swedish Energy Agency has developed a number of scenarios. These aren't actual prognoses or projections, but scenarios of how we could reach this target of an additional 100 terawatt hours. And whether we look at a wind-based scenario, a solar power-based scenario, or a focus on combined heating and power, in any of those scenarios, we anticipate a large expansion of wind power, which is what you see in the light blue on the top of the columns. So in any scenario, there's going to be a requisite of a lot of wind power development moving into the future. The objectives of the strategy are to contribute to the energy transformation to renewable energy sources and to develop a consensus, especially among government actors, but in society, as to how we can have a sustainable wind power development and how to deal with conflicts of interest between wind power, environmental objectives, and other interests, and then to provide a clear and unified policy from the government. This is going to be done through, first and foremost, collaboration and dialogue. The directors general of several of the agencies in Sweden, government agencies, have been meeting together, from the Swedish Environmental Protection Agency and Swedish Energy Agency, with other agency directors and other key actors that are involved in the planning process. So after having defined this problem and looked at how we need to develop wind power sustainably, we look towards the national planning tools that are available and how we can continue to develop those tools. And so there are a number, of course, competing interests involved in wind power planning. Everything from reindeer herding to defense interests. All of these interests in many cases overlap, and we need to identify areas where there's less conflict, where wind power is more able to be developed. And we're going to develop these areas and outline them and develop maps that are going to point out the areas that are full of less conflict-filled areas compared to those areas that are more conflict-filled. And in conjunction with national planning guidance as to how planning can be done in a way that's sustainable, we'll be able to develop a strategy that takes into account multiple interests. In combination with this, we're going to identify regional targets for every region in Sweden of how much wind power we believe is possible for them to develop within their region. And as you can see, there's much more access, for example, to good areas in the north of Sweden, but that doesn't negate the fact that in the southern parts of Sweden, there's a lot of energy consumption. And so we're going to have to weigh the pros and cons of different areas when developing these regional targets. We're also going to conduct a legal and regulatory analysis to identify areas where the legal framework can be adjusted to promote a sustainable wind power development, and also discuss in the strategy how it's to be implemented after the strategy is developed. So the strategy as such will combine these planning tools with national guidance, as well as regional targets and suggested legal and regulatory measures or changes that need to happen in conjunction to provide a strategy that can be implemented to plan for wind power. Once the strategy is developed, we're going to deliver the strategy to the regions in Sweden, who are then going to conduct regional analyses to take in factors that we can observe at the national level. And after they have done these regional analyses and planning, they'll work together with the local municipalities to develop wind power plans and identify areas that are the most appropriate for sustainable wind power development. And then we will be able to observe if we're able to meet this goal of 100 terawatt hours additional electricity production. So further information about this National Wind Power Strategy can be found at the following websites on the Swedish Environmental Protection Agency. And there you can go to find out more details of the planning and the timeline. But in short, we hope that this wind power strategy will be able to provide a concrete, unified guidance and policy from the government that will assist in reaching our goals of wind power development in Sweden. Thank you very much for your attention.
Thank you very much, David. Very interesting to hear about the work with the strategy. And I don't know, is the strategy unique for Sweden in a European perspective?
The way we're going about the strategy in Sweden is quite unique. We've seen other efforts in other countries. For example, in Norway, they developed a strategy for wind power development. But in contrast to Sweden's strategy, the Norwegian strategy was more about identifying areas from the national level top down where they believed that wind power would be able to be developed. And a difference between that and what we're doing is the national government in Sweden is trying to provide guidance and tools to regional and local planners who will be able to plan for wind power development. So it's not so much a top-down effort, it's an effort to aggregate planning tools and to ensure that we can have wind power developed in places and in ways in Sweden that are both sustainable and meet our electricity consumption needs.
You were talking about some of the challenges because obviously there has to be challenges in this. What would you say would be like the three most difficult ones?
Well, it's hard to say from looking from a bird's eye view at the national level, but we have identified some areas that are more challenging than others. Of course, there are expansive defense interests that Sweden has. Yes. There's a lot of areas in Sweden that are identified for example, low-flying areas for airplanes in the military to practice. That's a challenge because that takes up a lot of area as well as other defense interests.
It's close to 50%, isn't it?
Well, when you take everything together, yes, and that provides a definite challenge. However, we are in a dialogue with the Defense Department Ministry in Sweden where we're talking about how we can reach solutions and combine wind power with defense interests.
Mm-hmm. Good. I was also thinking about, because you have to, of course, have a good dialogue with the municipalities because wind power is not being built in the cities. But you also have to find the spots where you have the best wind. And that is, of course, a challenge because I know all the companies are really searching for the best places. And now some of them I know are a bit afraid of that this is not going to be the number one to find the best place where you have the best wind. You're going to talk about other interests before. What would you say to the industry and that remark?
Yes, so we've identified as part of the strategy, of course, one of the prerequisites is that we look at areas that have good wind power production possibility. And when we look at those areas, there are some areas that are less conflict-filled areas that are more accessible for wind power that can be developed. However, many areas are in areas where there are conflicting interests. And the important part of this strategy is to identify and say, look, we can't have a situation in which municipalities and other planners say, oh, it's always going to be built somewhere else, someplace else. This strategy is an effort by identifying regional targets to help municipalities to work together to achieve those targets and feel a responsibility for their portion of developing wind power. We see in some municipalities, of course, they're very enthusiastic and very good about doing this and they're forerunners in this area, and others that maybe struggle a little bit more. So this is an effort to collaborate and take some big perspective look, a big picture look at how we can develop wind power where everyone needs to contribute in a certain way.
Are you also discussing the possibilities of jobs? Because, of course, that would be one of the main things for the municipalities. If you can have more jobs, more people, more tax, etc. Is that being discussed or is it a parallel discussion?
Well, it's partially integrated into the strategy, a discussion of how we look at economic development, especially at the local level. The Swedish Energy Agency has also recently financed the what we call the Center for Wind Power, Vindkraftcentrum, which is a center based in the north of Sweden, but that has a responsibility to look at and investigate and communicate the benefits that wind power has for local economic development. And we believe that that's a way that we can help municipalities to understand not just how wind power can be a challenge, but also an opportunity.
That is, of course, important since much of the discussions are around people in the cities deciding on how things should be done in the countryside. That's always a challenge, regardless if it's wind power or other areas, I would say.
Yeah, and we've conducted an analysis of the different alternative ways that local communities can benefit from wind power development. And that's one thing we go into in the strategy is discussing, well, what are the different options that the government, different paths the government can take to help promote the local economic development from wind power.
Okay, thank you very much, David. So we will come back when we have a small chat with all the participants a bit later on.
Thank you so much, Charlotte.
Thanks. So now we have come to the last presenter, Hanley Hottingen. She's a principal scientist at the International Energy Agency, and she works with a forum that has exchange of the knowledge within this area. And she will speak about the transition to a 100% renewable electricity system, the opportunities and the challenges, and the role of wind power as a backbone of the electricity system. So, please, Hanley.
Thank you. I hope you hear me well. Greetings from a cloudy and rainy Bangkok to hopefully sunny Sweden. Thank you for inviting me to present on this exciting topic of how wind and solar could be the backbone of the power systems. I will talk about the energy transition, the challenges and opportunities, and also the role of wind power. So for sure, there is a huge challenge for the countries that will mostly build wind and solar when they are decarbonizing their energy systems. But just showing an example of Denmark here, that you start seeing the challenges already when you have about 40% annual share of wind that is shown here by a light yellow line, and you start seeing that the hourly points of instant share of wind are a lot of time already above 100% when you provide on average 43% of electricity by wind power. So this challenge will be for many of the systems, even the ones that go not towards 100% of wind and solar. And we also know from another example of the small island power system of Ireland, they have done a lot of studies how much they can allow wind to produce instantly in 1 hour. And they came to the conclusion that when it's more than 80 or 90%, then the current way the systems are operated will no longer be valid if there is a sudden failure, whether the system will cope and be stable. So the challenges are really this stability challenge. I'm talking here about VIBERs, which is variable inverter-based renewables, to highlight that it's not just the variability that is challenged, it's also the asynchronous inverter connection that is different from wind and solar. Another challenge I'll talk about is the balancing challenge for short-term flexibility, but also long-term flexibility and adequacy, and also the market operation, the how to design the markets for new grid support services and how to pay for them. So as we already heard from Wind Europe, electrification is happening at the same time. So it's also a load transition that we are seeing. And this will bring new electricity demand that is also a bit different than the current electricity demand. From transport sector, from heating, and from the industry. And this will create also opportunities. So at the same time, we see technological improvements in the grids, the smart grids that will enable the distributed resources, consumers becoming prosumers, producing some electricity their own with PVs, having storages, having energy management systems, these home or building energy management systems that already can be automated and operate with price signals from the market. We have a saying here in Far East that things are same, but different. So I would say that this is like, we start seeing aggregators and prosumers, and we see the current load, and it's sort of same, but different. Whereas this load transition from electrification, then we start seeing totally new types of loads that it's no same, no, very different. Also, wind power plants will have opportunities. This is because we are not yet using all that the inverter controls can produce for the grid support. And I'm showing this an example from last year that for me was the most exciting and inspiring example from Texas. They are showing a decreasing trend of their regulation reserve requirements in the power system. And this is partly due to that they put all their big wind power plants to provide primary frequency control, so the fastest response that the power system operators take. And actually wind power, through the controls of inverters, they comply always exactly as should, and they are very fast, faster than, for example, hydropower or conventional generators. So this means that actually there are capabilities of wind power plants that can also enhance the system operation and be very valuable. And also they can produce more than today. They can be made to mimic the conventional synchronous machines that we see today, but even then having some stability benefits. Anyway, the stability challenge as it is, and already seen in also the Nordic system for some light load hours, is that when from the big generators from the present grid are reducing and we get more and more these small generators through inverters, this means the whole system becomes very light. And then the challenge is that if there is a failure, if one of the bigger masses drop away, how the whole system will start finding the new stability. Well, wind turbines, we say it's all brains, no mass when we talk about inertia. And maybe this is even better than the physical inertia. Let's see, at least it has opportunities. So we have these options to still keep some of our existing big generators online, or build synchronous condensers, or turn them into synchronous condensers when they are otherwise going off the market. We can speed up the frequency response like I showed for Texas, and even it's now in Ireland tested an even faster response. Or we can make these inverters behave even better. So we can actually already today produce for wind power plants grid forming inverters, which means that they would be the ones who actually set the frequency and voltage and keep the system going. Of course, not all the wind turbines would need to do it, but for example, 20% of them would do it, and the others would be as today, grid following. But we could actually do this. Theoretically, it's possible. So my question already my answer to the question of this title, this presentation is, at this phase, I say, yes, we can do it. Okay, then the balancing challenge. The short balancing, I would say that it's more about, we have already a lot of options. We just need to use them more. So we can use fibers, we can use wind and solar, we can use loads, we can use storages, and they can provide the support services, the short-term grid support services that are needed today. Through electrification, we have new loads that hopefully will be more flexible than the loads today, even longer scale, even perhaps on a weekly scale, to have some flexibility. And then, of course, we need to change the operational practices and tools that the system operators use to enable all this happening. Long-term flexibility challenge is still more tricky. How to do this? Traditionally, we check that is there enough generation capacity to provide even the highest peak load hours? And then if not, we need to build some peakers, gas turbines. Cheap to build, expensive to use, but if you use them only some 100 hours a year, okay. But when we start really having a lot of wind and solar, this traditional approach will become very expensive. So we could either really use the flexibility of the loads and the energy system coupling loads, thermal storages, and through that actually get a lot of this security of supply reliability. Or the storages, perhaps they come really, really cheap, and we can start using a lot of storages in the system. That's another way. So probably a mix of all these three would take us there. we could do it. The markets, of course, need to be also changed. So we have already now we see that some hours of the year when there's really surplus of electricity, the market prices will go to zero. So flexible loads will also press down the market prices. However, they also can help a lot, because when we go to really towards zero market prices, then these flexible loads can start operating, and then the prices don't drop that much. So that is the big question also for the future, if storages and loads will help in this sort of cannibalizing effect that wind power has. Then another challenge is to really set the right price incentives for all the market prices, so that the flexibility will be there and the system support services will be there, and especially in the transition phase, how to take these sort of introduce these so that there is enough market and use for these services also. So finally, the local flexibility. This is also a challenge, how to really use this for the system benefits, because we start seeing these local flexibility markets, very interesting. We start hearing about peer-to-peer and energy communities and everybody trading with each other. And when we do this, we may actually lose the system benefits. So the vision for future system is that you will have this local smartness and a ability to balance locally. But if you have the big system, you would still use the flexibility where there is most value at the system level. So hopefully not coming like this, when the Internet of Things really doesn't start working, but they will just, start arguing with each other. Hopefully not that. So then finally, the wind, something about the wind science. So there was an interesting science article written by IEA Wind, or coordinated by IEA Wind. And the third challenge there was the grid challenge. So it's about how you take all the knowledge of the wind fields and your power plant capabilities and use it for the grid. So it's not just to provide low-cost energy, but also to provide resiliency and reliability for the power system. And this is to do a lot with controls, not just for power and energy, but also for reliability and the grid. And then you can add value and also have these new capabilities like the grid forming for these situations where you really want to have wind as a backbone of your system, and really use the controls to access all the possible flexibilities that could be available in the wind and in the turbine rotor. And of course, you need a lot of data for that. Okay, so I summarize and end my presentation by just listing that my answer was yes, wind and solar can be the backbone, but for sure you need more research for that. And actually you need a lot of pilots and demonstrations for the system operators to trust it also before they can really use it. So you really need to look for new paradigms of operation for stability, and the markets for the operation and balancing, and for the adequacy also you need to shift from the fixed load paradigm to this flexibility that is available there. And then for wind turbines, really these wind power plant controls and more capabilities like grid forming, that's the key. So I have just added some references here, and then I thank you.
Thank you very much, Hanley. I do like to hear your presentation because it seems like you're hopeful for the future. And when you speak about the backbone, I think that you're also talking about that there is a possibility for wind power to be a backbone already 2040? Yes?
Yes, there is. Yes, there is. But I must say that that needs to be prepared for. So I don't think any system operator today would still run the system like that. And also what we don't yet have sort of proven robust operation in that we can go like fully wind power operated system and then back again with synchronous generators and go back and forth smoothly. That, you know, for that to happen, you need to move from the research of simulations to actual pilots and demonstrations and have new tools. But of course, 20 years and these are now currently research topics. So yes, I'm hopeful that in 20 years this would be possible.
Good. I was also curious about the work at the International Energy Agency, but maybe I will save that one for the debate. So thank you for your presentation.
Thank you.
So thank you, Pierre, David, and Hanley. I have you there, Pierre. I have you there, David and Hanley. Where do I have you? Maybe you will be on the screen as well. Yes, I think that most of you, all of you, you're quite hopeful for the future, and then of course one important thing, as we spoke about, was also the permitting processes. Maybe if you, Pierre, would speak about the situation more in Europe, and then we will go into the situation in Sweden and how really the strategy could address this very, very crucial question. Because just some figures, I've seen that about half of the applications now are rejected, and between 2017 and 19, you have a decrease of 70% of applications. So please, Pierre, elaborate a bit on the European situation.
Yeah, what we're seeing at the moment is a bit of a conundrum, right? Where European countries are really starting to, put in place the policies in order to drive up renewable energy volumes. But at the same time, so they're coming out with these auctions. But at the same time, a lot of these auctions are undersubscribed. And this is something that we've seen, for example, in Germany, that you have a volume of 400 or 500 megawatts that developers are meant to compete for. And there are only 200 or 300 megawatts of projects. It's not that the projects are not there. The projects are in development. But they're stuck. They're stuck in permitting, or they're stuck in legal challenges. And therefore, what we're really advocating for is for national governments to really put in place what's already been actually agreed as part of European legislation. It's two critical things. First, it's a notion of a one-stop shop where you have a single authority that you go to as a project developer in order to get your permits. If I take an example in my country, in France, the government is trying to streamline the process, but still a few years back, you needed to go to 19 different authorities in order to get your permits. You may need to go to the local city council, to the préfet, to the representative of the states, to engage the system operator, et cetera, et cetera. All of which leading to an administrative nightmare that has no added value in terms of making sure that a project is well developed, factoring in environmental concerns, but pure red tape, if you will, right? And this is something that we really need to sort out. So the one-stop shop is absolutely critical. And then the second thing is to really implement now the binding lead times that have been approved as part of the Renewable Energy Directive, which is 2 years for a new project, well, 3 years maximum for a new project and 2 years for a repowered project. And if we're able to do that, of course, complying with this will require actually the authorities having the right staffing and having proper resources in order to deal with all these permit applications. And if we do that in every single European country, then we're able to actually get the quality projects online and to grow the share of wind in the mix.
Thank you, Pierre. David, the question for you. How is the situation in Sweden? I guess it's not that bad. 19 different agencies handling an application. How's the situation in Sweden?
Well, about 11 years ago, there were 3 basic different permits that you needed. You needed, first of all, the building permit from the municipality. You needed the environmental permit. And you also needed a concession to be able to connect to the grid. That was simplified into basically 2 permits and an approval. The permits are still the environmental approval permit and then also the connection to the grid. But in order for municipalities who were in charge of the building permits not to lose their influence over the process, they were given this veto power that we call it. And this veto power basically means that the municipalities are responsible for approving each new wind power project within their municipality. The problem with this, in contrast to the building permit previously, the building permit was a legal process where there could be appeals and where you had to receive this permit. The current municipal approval is pretty much an entirely political process. It's not necessarily grounded in the law in any particular way, except that it's required as a step to be able to attain the approval. The difficulty we see with that is that it is entirely political. What we've done in the strategy, the National Strategy for Sustainable Wind Power Development, to address this is 2 things. The first thing is that we've tried to take a planning approach that is going to address many of the local concerns at the planning stage, hopefully, rather than at the permitting stage. And we hope by having a good process, it's an inclusive process of planners at the regional and local level, you'll have people contributing and being able to decide on areas that will be good for wind power development. That will hopefully help. You'll still have the permitting process, though. And to address that, we've also suggested some changes that the Energy Agency has previously recommended that we think maybe have a little bit more political support right now. For example, that a municipal approval should be given early in the process rather than simply being able to come in the last minute and stop a project later on. And so in those 2 ways, we hope to be able to address some of the permitting challenges.
Good, because initially you wanted to get rid of it, didn't you? That was a proposal to the government that you said, this is not working. It's not from a legal point of view. It's not correct to have this type of.
Yes, exactly. The building permit was a more legally sound process. The problem with that was, and the reason why they got rid of it was you had this double permitting process going on. So you get permit from one side, but not the other. But in the effort to do that, it kind of too quickly moved over to this municipal approval. And so we advocate a more legally sound process that comes earlier on. And we think that could help at least a little bit in the permitting process.
Will it still be possible, even though it's early in the process, will it still be possible to sort of change your mind that has happened in the past, that the politicians are sort of changing their minds? So 1 year from finalizing a project, they can say, sorry, but I'm not pro this any longer for political reasons.
Well, currently that's the case. I mean,
Yes.
currently they can change their mind. They can initially say, yes, we're going along with this. And then if local protests or a local movement against the project arise, it can lead to pressure on the politicians to then withdraw their approval, which can be given or taken away anytime during the permitting process until the permit is granted. Now, again, we're trying to circumvent that by having it be required to come early in the process and then be binding after that point in
And then be
time.
binding.
That's our recommendation. Now, of course, we'll have to see what the government does with that recommendation that we're making.
And it depends also what the different political parties thinks of it, of course. And it's different on a national and a local level, of course.
Of course.
Yes. So I would like to focus a bit also on the needed electrification. I mean, we still have a lot of fossil fuels in Europe, and we do need more electrification. We need more electricity. And I think that you, Hanley, in one of your pictures, you said that there was going to be a doubling between now and 2050. So my first questions to all of you would be, is that doable? Is it going to happen? Because we have had this discussion for quite a long time. There's going to be a greater need. There's going to be a greater need. And the level has been, for the past 20 years, at least in Sweden, more or less stable. So what do you see? Is this going to happen 10 years from now, 20 years from now, or is it 2050? Maybe, Hanley.
Well, we certainly hope that it will accelerate the speed of electrification. Now, we do see clear tendencies towards that and good examples like Norway with electric cars, that it can happen and it can start. But for sure, there is always, it always takes some time. For example, in Finland, for the power to heat case, we've had our Helsinki municipality or the electricity works who, because of a ban for coal was set. So they are now moving towards using heat pumps, big heat pumps and huge thermal storages in the district heating network of Helsinki. So these things are sort of good signs that yes, it is happening already and it is possible. But I think it really does need push and incentives to happen.
Yes, David.
Yes, I think it depends. It's different from sector to sector with electrification. We see in the transportation sector, of course, the increase in electrical cars, battery-powered cars. And in Sweden, the Swedish Energy Agency has, for example, financed the Hybrid project, which is designed to produce fossil fuel-free steel. Things like that will lead to electrification. However, things that will compete with that is, for example, in the north of Sweden, where there's a lot of electricity production that's relatively cheap, you also see that not just being used to electrify the society as a whole, but you also see on the demand side server halls from major, technological corporations being established there, and that's kind of sucking up some of that electricity. So there's a supply and demand aspect to it. There is electrification happening, but then there's other sectors such as buildings and other areas where it's in agriculture and land use where it's moving much more slowly. But, of course, an increased wind power production would push down prices, enabling a cheaper and more efficient electrification of society.
Yes, so part of it you've been answering about which areas would be the most difficult one to electrify and the reasons why. But maybe, Pierre, from a European perspective, what do you say?
Yes, certainly. I mean, I think the first thing to bear in mind is that the level of electrification today is relatively low, right? We're dealing with a level of electrification EU-wide of just under a quarter. Our assessment, and Hanley has shown some of the material from our report, Breaking New Ground, is that the rate of direct electrification could reach 62%. And I think there are a number of things that need to happen here, many of which we've discussed. continuing accelerating the deployment of very competitive wind and solar to keep making electricity competitive. We need the infrastructure in order to be able to roll that out and make the right investments. And we also need to amend and adjust regulation and taxes in order to incentivize consumption of electricity. A lot of the time at national level, actually, the tax burden on electricity is higher than if you're consuming fossil fuels. And that's something that needs to be addressed as a matter of priority. So there will be the regulatory pushes, and there will also be some important market developments. We were just discussing very large corporations, and for example, Google has recently come out with a commitment not only to have a completely clean electricity supply, but to do this around the clock, right, 24/7. And part of the way that they do that is really by innovating also on having as flexible a load as possible. And by having some corporations show that this is possible, this is also charting the path where we have not only a flexible electricity supply, but also flexible demand, where actually electricity is able to meet the energy needs around the clock.
It seems like
I could also.
Sorry, just a follow up. It seems like it's very important for your companies in the wind energy area to connect with the companies that do need the electricity and hopefully the renewable electricity then.
Exactly. I think it's really critical. For example, we're working with the European Union to connect wind farms with a trans-European network for fast loading, charging stations. And I think here, power purchase agreements that are really able to link directly the wind energy assets with the consumers will play a very important role.
Yes, Hanley, you were just going to comment on something.
Yes, I was also going to just comment or add something more about this flexibility, because what we see is that when we have a power system dominated by wind and solar, all this flexibility and also the flexibility longer term is crucial to have from the loads where it's cheaper, more cost efficient to realize. And this actually, I think, is very important that also the regulations are there from the start when we get these new loads that enable them to be flexible, that there is the capability of flexibility already when they connect to the grid, and also possibilities to use that flexibility, and also incentives that it's good to use this flexibility. For example, the electric vehicles. So most of them, even if we have known from the start that the difference between a dumb charging, you just go there and you start charging full, or smart charging, you charge during the night when it's best for the system and cheapest for you. So we have known this from the start, that there's a big difference, and still electric cars just, for example, in Norway, they just came like that with dumb charging. Of course, you can do it later, and these flexibility markets, local flexibility markets in Norway have a demonstration just to deal with that. It's also possible that way. But I think there is room to think beforehand also for the regulative framework for these new type of loads.
I'd like to add something there. In terms of wind power's contribution to flexibility, I see two things that would need to happen. One is that there needs to be a spread of information about the possibilities of the system services that wind power can provide among wind power producers. The wind power industry in many parts of the world is just barely entering its adulthood and maturing as an industry. And with that comes a deeper knowledge and understanding of what sorts of additional services besides pure electricity that can be provided to the system. So combining a spread of information among wind power producers of what they can do to add value to the system is important. And then the second factor is a restructuring of markets for such services that will allow the incentives for wind power producers to maximize profit by providing system services to be realized. Those structured markets, in many cases, don't really exist today in the way that would be needed for a distributed power system like you see as we move to systems that are primarily dependent on wind power as a major generation source.
That was actually one of the questions that I was going to pose to you, Hanley, about the situation of the power plants and what they are lacking today. But you sort of gave the answer that they could have an important role also for stabilizing the system. But I mean, since the different sources of electricity are changing, so there has not been a need for that from wind energy, as I see it. So I guess there is also the industry itself has to sort of promote that this is something that we could do from the turbines. They could sell that. And I don't know what work is going on within Europe. Is this heavily being discussed among the different turbine producers, for instance, that we can deliver stability to the system? Do they have to add something to the turbines, or is this something that is in place already now?
I think that part of the capabilities is not so very expensive to add for the wind power plants, but part of them would actually need some remuneration for the services that they are providing. And I think this is also an ongoing debate, that which parts of the capabilities you can just say that that's a grid code, it's a grid connection requirement, you have to have this capability, and which are the ones that, yes, this is a capability that you will give, and when we need it, we pay for you. There is a remuneration. So the markets are moving to that direction, which I think is a very positive thing, and all these services to the system should have a price and value and remuneration. Also, I have to say that some of the first demonstrations for wind power plants providing these services, they were very disappointed how little it was needed in the system, because there were other conventional generators that could do it more cheaply, because they didn't have to lose any energy by doing it. But I have been telling them that, yes, don't worry, it will come. We see it from our system simulations that once you reach the 20% share of wind and solar, then these services start to become also cost effective from the system point of view to use from wind power plants. Of course, first you will use them when there is surplus energy and there are not so many others to provide it. That's like how it starts. But then these hours are getting more and more in the year, and then you start using more and more also wind power in these services.
Okay, I do have some questions here from you viewer also, and there's one for you, Hanley. It's talking about, you were talking about flexibilities and the big challenge there. So one is, do you see barriers to accessing all potential future flexibilities?
I see barriers as sort of more like regulative barriers and market barriers. So if we don't set the regulations and the market incentives right, then we may have very much flexibility there in the new loads, but it's never used. They are just operating according to some tariffs, for example, or like that. So the future power to X will use a lot of electrolyzers, and so far electrolyzers are so expensive that when you make the investment, you want to use it as many full load hours as possible. But once we see the prices go even a little bit down, I foresee a future where, for example, you would use them 6,000 full load hours a year, and that would give you more than 2,000 hours sort of flexibility in when you use it. So you could, when there is scarcity of generation, you wouldn't use the electrolyzers. And when there is surplus of electricity, of course, you would use it full speed. So just to enable these things to happen, you also have to think about the regulative environment and also the price signals from the market.
There was also a question which I think addresses you, Pierre. It was one of the viewers. You were giving attention to your slide about the energy and climate plans, and that you have excluded Sweden. Is there a reason for that?
No. There's no particular reason for that. I mean, that was a bit of a snapshot of some of the countries that we examined. I was not able to share the entire 27 analyses of the plans, but they can be consulted on our websites and in full detail. I think the tendency is clear across the different national energy and climate plans. The challenges are basically the ones that we've been discussing, right? Which is making sure that the permitting procedures are as clear, transparent, and straightforward as possible. Making sure that all the levers are, activated to drive up electrification, and making sure that there's clarity for investors on what types of auctions are coming and what types of remuneration they're going to get in that context. And here we're very much advocating for the contract for a different system, whereby there's clarity for the investor, for the financier, and for the governments on what this is going to cost the society. This brings investment costs down and means large-scale deployment at least cost for society.
Thank you. It's not Christmas, but it's getting closer. So if you could just make one wish to our politicians, it could be the one on a national level, on EU level, international, whatever. I start with you, David. What would your wish, or what would simplify your work in order to meet the aims of both sustainability and renewability to 2040, 2050?
I think it'd be a realization that wind power and other sustainable development goals can coexist. Whether that's wind power and environmental impacts, or preserving species, or wind power and local economic development, that these are not goals that are incompatible. So an understanding of that is the beginning to reaching real solutions that can provide for our electricity needs at the same time they meet the other sustainable development goals that we have.
Thank you. Pierre, your wish would be?
My wish would be for the policymakers to fully connect the dots between the grand climate ambitions of climate neutrality by 2050 and the milestones that we have in front of us, and in particular 2030, to connect the dots with all the other policy areas. Making sure that when it comes to defining priorities for funding infrastructure, that all of that goes towards achieving that objective. Likewise on electrification, and likewise on national policies for planning and permitting. And with having that common through line is really the way that we're going to deliver, and ultimately policymakers can go back to their voters and say, we did it.
Thank you. And Hanley?
Well, I would hope that the loads, that they would enable the loads to become flexible in that way, that they will allow as much price signals to be seen by consumers and the new loads as possible.
Thank you. And thank you very much, both David, Pierre and Hanley, for this talk about the future, what is needed, and really that we are on our way, but still there is a lot to be done. Thank you very much.
Thank you.
Thank you.
So, thank you very much to the speaker, as I said before. And really, very much is happening, as you heard from the three speakers here, and also what they more or less all addressed, to have a closer debate among the different policy areas, to see that they connect and doesn't go the opposite ways. That's very important in reaching the goals, the climate goals, obviously for all of us. So I think that that's the key thing that I bring with me, and also that there is a great hope that this is achievable until 2040. We will have a renewable society, we will have a sustainable society. So I think that will be my final words for this session. So, and for those of you, I hope everyone, will go to the parallel sessions. There are some instructions that you see on a picture here also. You should use the button that says all participants, not only the speakers that maybe you've been using. You should hover over your name. Click on more and rename, and then you put the number of the session that you would like to enter. It's 3 different sessions, so you could put 1 and then underscore and then your name, and then you click OK. And then the host of these 3 different sessions will see to it that you get to the right session. And then it's the end of my session, and I would like to say thank you to every one of you. I wish that you would have been here and that I could have seen you, but thank you very much for the participation and the questions, and enjoy the rest of the day. Thank you.
Hello and welcome back, everyone. I hope you had an interesting day and that you learned a lot through this conference. My name is Åsa Elmqvist, and I am here to guide you through this concluding session. First of all, I would like to say that we are sorry for some technical difficulties that some of you have encountered during the parallel seminars. But the good news is that everything is recorded, so those of you who have missed some parts of the sessions will have the opportunity to look at them after this conference. I will take the opportunity to introduce the moderators that were with me moderating the parallel sessions. And for this we have Sara, we have Stefan Ivanell, we have Stefan Ivarsson, we have Tanja Tränkle, and we have Pierre Tardier. And they will summarize the different sessions that they were hosting. And I will start by asking Stefan Ivanell if you could share with us what happened during the very secret session in room 3, this last session that were the IEA task workshop that was close to the broad audience. So what did you do there, Stefan?
Thank you, Åsa. Well, if it's secret, I will not share anything, but I guess we should not keep it secret, so I will share what we discussed. What we did was that we gathered the IEA tasks that are represented by Swedish participants in the IEA wind activities. And we were around 10 persons, and we gathered around also 10 tasks. And I will not go into all details in all of these tasks, but to mention what task we are involved in. So we had the task 19, cool climate. We had task 25, large amount of wind power. And here we also discussed that looking at system perspective on the power system, wind is always a part of it today. So what is actually wind and more general here, but at least we have this in the IEA wind, large amount of wind power. And then we had 2 projects, Next and Wakebench, which are related to aerodynamics and flow modeling and farm optimization activities. And then we had one on cost of wind energy. and REEN, which is the environmental task, and we have one forecasting, which then is the wind forecasting, and one on social acceptance. And in addition to this, we also have a few that we are about to enter, which is the quiet wind, which relates to noise, and then OC6, which is offshore activities. So there's also one coming up later on, which is more related to farm control. So we are active in quite many IEA tasks, and what we discussed today was to share experience from different tasks, how these activities are aligned with the strategy of the Energy Agency. And overall, we think that the IEA activities are very positive because it really joins you up with international expertise in these different areas. And there are some challenges in how we are financed. We are financed to take part in these meetings, etc., but we still need parallel activities for doing actual research within these activities. But overall, this is very positive. We meet up the international expertise. It results in international benchmarks, international collaborations, and a lot of publications. So overall, I would say that this is a very, well, the impression from all task activities are very positive, that this is a good thing that Sweden are involved in this. And we discussed how we can increase the collaboration with the Energy Agency and synergies between these tasks. So this was what we discussed today.
Okay, thanks a lot. Then I will give the floor to Pierre Tardier, who was moderating the session about innovation and entrepreneurship. Please, could you share a summary of the main focus areas from your session?
Yes, thank you. So, I think we were able to listen to 3 very interesting presentations of 3 young companies that presented their innovation. We had first TensionCam with an innovative bolt that can monitor remotely the clamp force of a bolt in a turbine. The goal is to increase reliability and reducing the cost of the work for monitoring these. And they will have their first on-site demo this year. So if you want to have such a bolt that you can monitor from distance, then you should follow this company. Then we listened to Seatworld, who presented an innovative floating vertical axis wind turbine, offering simplicity and robustness compared to. So floating wind is a low installation of wind power into deep waters, releasing a large area which is not available with today's technology, with bottom fundament technology. Their goal is to solve a number of issues like blade erosion. This will be solved by the vertical axis, but mainly they want to reduce the installation and service complexity for offshore wind. And they got a large EU funding to test their first 1 megawatt turbine in Norway. So this would be also a project, an ongoing project to follow. And lastly, we listened to Modvion. Modvion is a company developing a modular wood tower. And their goal, one of the big thing with this wood is that it reduces the climate impact by 90% compared to steel, while being a carbon sink. And a long-lasting carbon sink. They describe that their wood could be even be used after being in a tower. They could be used in furnitures and finally in papers. So it could be a very long-lasting carbon sink. And then they also say that, and then you burn it and you have CCS and you get a negative effect. Very interesting. And they also got a large EU project funding, and the goal of this project is to demonstrate a 110 meters tower. They got recently in May this year demonstrated or put together a 30-meter turbine tower. But the next step is a 110-meter tower. And their goal is of course to do up to 150 or more towers. Three very exciting projects, I believe, that show that you can be very innovative within wind power.
Yeah. And I know you said that it was also three very good presentations, so everyone who missed it.
Very good. It was very good quality.
Yeah. So all of you who didn't listen to it are encouraged to do that afterwards. Thanks a lot, Pierre. Then we move on to Chalmers and Sara and the session Integration of Wind Power into the Electricity Grid. Please, Sara.
Yes, thank you. Yeah, we had 3 interesting talks here as well. One focused on the frequency control in Sweden today. And today it's mainly hydropower that's used for frequency control. But with more and more wind power in the power system in Sweden, the wind turbines also need to participate in the frequency control market. So the project will talk about how or develop models to see how turbines can do this in the best way. And then we will test the methods on Chalmers wind turbine, but we will also use commercial wind turbines to see how they can participate in the frequency control market. Because there are a lot of models, but we also see how to do it in reality. Then we had another project that will see how we can use wind turbines to start up the grid after faults, black start turbines. Today we are using a hydro unit up in Luleå Älv for starting up if we have a grid fault. So the idea is that you go from bottom up here instead. So wind turbines create power system islands, and then you can expand the islands, and then you can connect them and grow larger and larger system. And it's also, you have to, when you connect to islands, you need to synchronize them. So it's not just to plug them in. But this is a way to help speed up the process of reconnecting the grid after faults. The third part was, my talk was about that we use more power electronics in wind turbines today. And this will then cause complex interaction between converter controls in the turbines and other parts of the grid. And then you end up with harmonics and resonances phenomena in the grid. And the project will learn more about this harmonic stability in power electronically dominated systems in order to see how can we minimize the risk for system instability. Because these power converters that we use, they can help with frequency control, for example, and other system services. So that's why it's positive to use them, but you also have some problems that you need to mitigate. And in the end, this will lead to more wind power in the power system. Yes?
Yeah, thank you, Sara. Then back to Stefan Ivanell and the climate's impact on wind energy.
Yes, and here we also had 3 very interesting presentations. And maybe this was the session where we had largest technical issues. Today, we actually had to have 1 presentations in the session after lunch, but we managed that. But anyway, we had 3 very nice and interesting presentations with the focus on climate impact on wind power. And first, there was a presentation on the complete model chain for icing, where one is trying to starting from data from SMHI, seeing what's the probability or what's the conditions for icing, and then model the ice accretion on the blades. And then from that ice accretion modeling, take that into turbine modeling to see all the way to how does the ice affect increased loads, etc. So trying to close the entire chain from meteorological data to loads on the wind turbines. The second presentation was an experiment from stage 2 of the icing project. So really to avoid the icing that one could see in the model chain in the first presentation. And here's some innovative methods that have thin layers of heating on the blades and try to avoid icing building up there. And the third one was from SMHI, from the project Klimpen, the climate impact on the energy system. And here SMHI showed modeling the climate change and also showed an overview of how probable are different results from the climate change and how big impact will these different effects have. And looking at to increased or decreased wind speed, increased or decreased temperature, etc. But these general aspects of change in wind and temperature is quite limited and not very probable. But what was lifted out as the most probable and also has the largest impact is icing on blades. So that is something that was coming out from that report, that is something that will have an effect for the future. And it was also pointed out that even if the climate change in general has a specific increase in temperature locally, especially during winter times in Sweden, the effect could be larger. So there's some very interesting results there to investigate further.
Thank you. And you can continue with wind resource and CFD modeling.
Yes, I will do that. Thank you. So next session was the wind resource and CFD modeling. And then we had 3 presentations as well, also very interesting. The first one was on towards efficient high fidelity simulation of wind farms. And here it was presented new novel types of CFD modeling where we don't really solve the Navier-Stokes equation the same way as traditionally, but more with another type of numerical approach, which allows that one can use GPUs instead of CPUs. So Henrik that presented this show that compared to a supercomputer cluster, if you do this same type of modeling on the local machine with this approach, it takes about the same time. So the speed up is really a factor of 1,000, which of course is a very important thing considering farm modeling and the cost for farm modeling for the future. And then I presented myself validation of forest modeling, where we had some results from the New European Wind Atlas project and also from the national project on flow modeling of Swedish forested areas. And here I showed that we can today combine very detailed models of the forest with the turbine modeling, and the newer thing is that we can run this non-neutral modeling as well, which is very important since the real physics is not neutral. That's an assumption we've been using for some time. But now we can also run all this together with ambition to really have the big picture of the flow modeling, and from that see how the load changes on wind turbines depending on where you put them in very complex forested sites, for example. And then last, we had Christopher presenting recent reanalysis tideways over the Baltic Sea for low-level jets. And Christopher showed a comparison between different reanalysis sets and how they represent low-level jets over the Baltic Sea and the impact on that, and also pros and cons with different data sets. And NEVA was, for example, one of them, comparing how well does NEVA work in this type of Baltic conditions. That was that session. Thank you.
Okay, thank you. Then we're heading on to the societal and environmental impact of wind power, and that was moderated by myself, and therefore I will give the short summary. We were unfortunately missing out the first presentation on societal impacts, but we ended up with 2 great presentations on birds. One on Caper Cayley that covers a study on the mainland on Caper Cayley with GPS and dogs, finding out their behavior and see how they react in a wind park and in a corresponding control area. And the overall conclusions is that they actually do reduce their use of the habitat close to the wind turbines. And the other one on Gotland with checking out eagles, they used a camera to spot birds and to see if it is eagle and if it is in a dangerous position due to the turbines. And then they try to see if the turbines had to be shut down due to the approaching eagle, how much energy should we lose? And can we make this optimized in any way? And in both studies, they found out that no birds were killed. So every bird came out of these studies safely so far. Then back to Sara again, and a summary of wind power technology and operation.
Yes, this was a more mixed topic sessions, but still very interesting. We found out that there is much we don't know about foundations, but they seems to be over-dimensioned, that we can save a lot on the materials in them, so we can reduce the impact on the foundations so they get more sustainable. We also found out that by using dynamic transformer rating, the transformers can be reduced in size and cost. And also, if you use this dynamic transfer rating, on existing transformers, more wind turbines can be connected to the grid, the existing grid. So that is two benefits from this. So that's very promising. We also learned about active network management and how it can be used to increase flexibility in consumption, generation, and power transfer capacity. So the active network management utilized advanced controllers with increased monitoring and communications. Yes.
Thank you. Then we move over to Stefan Ivarsson and the session Electricity Market. What can wind offer?
Thank you, Åsa. That was a very interesting session, and I hope that all of you that couldn't join that look at the recordings, because it was definitely worth it. First of all, we started to learn about electricity from new power plants. And that's a cost study where we heard a lot about how to measure costs on a very good way. There were challenges. We heard about how to measure the LCOE cost, how to measure competitiveness, and also how to measure system cost and system values and the challenges that come with that. And the example of those challenges was how you could get the right and the different cost drivers aligned, how you could avoid double counting, but also how different legalization and different markets would have an impact on the costs and how to do that. So a lot of these things will be covered in this project, which is not really to the end yet. So they were just presenting their early results so far. So I think there's more to come about this. Then we moved over to agent-based modeling. Very interesting to see how we could get continuous trade in ID markets where we had bid and asks for the trading. And we also learned about how these different new ID markets were coupled in Europe and how this is expanding. So more markets will be integrated for this kind of agent-based trading. We also heard that the time horizon for the trading is moving from 60-minute bids over to 15-minute bids. And this will also affect the market and how it will act. This will mean more algorithmic tradings in the future. And we learned how these agents work a little bit. What information do they need? What do you feed them with? And how can this develop better trading statistics for the strategies for the future? And after that, we heard about potential and cost for wind power providing system services. And here we had a strong focus on the FFR services for the electrical grid. And we learned that the wind power today actually have 10% of the rotating inertia in the energy system. But we will need some changes to the control system to actually be able to use this. And we saw how this project had designed a robust turbine controller to be able to use the FFR. And the results they presented to us was that they could bring into the system about 430 megawatt of spinning reserve to a cost that is as low as 1.3% of the production. So this is very interesting for the future, and it kind of kills the myth that wind power can't be used for a spinning reserve. Well, we need to do some development, but that's what we are here for, to have some future research. Thank you, Åsa.
Thank you, Stefan. Then I will give the word to Tanja Tränkle and the session on recycling and repowering. Please, Tanja.
Thank you. And my first pledge is that recycling doesn't always end up at the end of a program of a conference, just because it's seen as the end of the life cycle in one way or the other. Put us at the first sessions of conferences, please, in the future. But for you guys that have missed to watch that session, if you take a look, you will learn about the different recycling options that are out there and their TRL level, which ones are available on an industry level and which ones are to be researched more on and also to be developed and upscaled. You learn about circular economy actions in general. Recycling is one of the last options apart from landfill. That means there's a lot to do before that, which leads me to that the tendencies that will have to be followed in the wind industry are to design for sustainability, and that means the material mixture needs to be in its complexity, be adapted for future recycling. That is one way, and the other one is that a design for a second use after the end of life as a wind turbine should be part of the design. And you will learn a lot about the chemical recycling method, solvolysis, where separation of glass fiber and polymers is possible to some extent. And I close here because it's just 2 minutes left, Åsa, and you need to close here.
Yeah.
Thank you.
Thank you, Tanja. Yes, as you said, we are running out of time, but I still would like to ask Stefan Ivarsson if you want to send some messages to the future about the remaining interesting questions for wind energy research that you want us to bring with us from today.
Absolutely, I can do that, Åsa. And I think what we can conclude after this day is that we have definitely a lot of remaining questions to answer. We have seen interesting projects, but we have also heard about possibilities for future research. And then I start by saying there's a lot to do still with recycling, not putting that at the end. But I mean, we see a lot of possibilities when it comes to digitalization that comes into the whole electricity system right now on a broad way. We see that when it comes to system services, we see it with the agents. It's very much digitalization, open data, machine learning, and so on. We see also how what we have seen as our limited wind power community expands into other areas with the sector coupling of the whole energy system, where different sector becomes dependent of each other. And we also see that all of this needs us to start thinking a little bit more about resilience of the renewable energy system. How can this be a reliant and a resilient energy system for the future? So I think I stop with that, but that is some of the real interesting questions we can work with for the future.
Yeah.
And there's a lot of opportunities out there. It's very exciting to work within research within energy sector right now.
So I hear that there is a good chance we will have some reason to meet soon again, because there will be new interesting topics to discuss.
Absolutely.
So with that, I would like to thank you all who have joined us today and who have given presentations and contributed in the sessions and in the chat sessions. And from the Energy Agency, I will let you know that there will be a survey sent out, and we are very grateful if you could answer that to let us know what to take with us and make even better the next conference. And also you will receive information when the presentations are published online, so you can go back and see what caught your interest. So thanks a lot, and see you again in a short while.